Okay, now we will discuss one more video. Ostwald dilution law. Ostwald's. Okay, Ostwald is a scientist. Actually, the extent of ionization of the substance is large. Then the substance is considered as a strong electrolytes. The extent of ionization is small or less is considered as a weak electrolytes. Okay, Ostwald he derived one equation or law by using of weak electrolytes only, but not strong electrolytes. Here, since weak electrolytes are not completely dissociate into its ions. Okay, what is a strong electrolyte? Okay, when electrolyte is dissolving in water, which can completely dissociate into its ions. Weak electrolytes, small extent means the extent of ionization is small, is called weak electrolytes. Okay, the Ostwald dilution law of weak electrolytes, you can observe here, the weak electrolytes are not completely dissociation. There exists, the equilibrium exists between, there exists an equilibrium between, the equilibrium between ions and unionized compounds or molecules of an electrolyte is called ionic equilibrium. There exists an equilibrium between the ions and undissociated molecule of an electrolyte is called ionic equilibrium. Okay, now I am taking one here. Ostwald applied the law of mass action to the ionic equilibrium. That is called Ostwald dilution law. He derived one equation. Then the equation is called Ostwald equation, dilution equation. Ostwald dilution law equation. For example, now I am taking one weak electrolyte. HX dissociate into H plus and X minus ions. At initial, the concentration of the reactant is a C, here 0. At equilibrium, C minus C alpha, where C is a concentration, alpha is a degree of dissociation. How many molecules dissociate into its ions? We don't know. That's why now I am taking here C alpha. Okay, by applying of law of mass action, according to the law of mass action, the ratio between product of concentration of product to the product of concentration of reactant, with each concentration term arised with some power. Okay, these are the products. This is the reactant. For weak electrolyte, now I am taking small a here. This is the dissociation constant for an acid or ionization constant of an acid. Okay, now I am taking at equilibrium C alpha into C alpha by, now I am taking here common 1 minus alpha. You can observe here Ka. This is ionization constant of an acid or dissociation constant of an acid. Ka is equal to C square into alpha square by C into 1 minus alpha C gets cancelled. Ka is equal to C alpha square by 1 minus alpha. For weak electrolytes, the extent of ionization is very small. That's why alpha value is very small. We can neglect the alpha here, denominator term. That's why it becomes equal to the 1. Ka is equal to C alpha square by 1. Okay, now here if you take this is equation 1, in case C is equal to C, what is the formula? N by V is the formula, where N is equal to 1 mole, C is equal to 1 by V. Instead of C, we should write 1 by V. What happened? Alpha square by 1 minus alpha into V. It is also one of the equation. Now I am taking this one. Okay, alpha is very small value. That's why Ka is equal to C alpha square by 1. Ka is equal to C alpha square. Now I want to calculate the degree of dissociation for acid. Now what happened? Ka by C is equal to alpha square, where alpha is equal to square root of Ka by C. In case now I want to calculate the concentration of H plus ion, here concentration of H plus ion is equal to the C alpha is the formula, concentration of H plus ions. You can observe here. Okay, this is here concentration of Hx is nothing but at equilibrium is C into 1 minus alpha. Concentration of H plus ion is equal to the C alpha. Concentration of X minus also C alpha. Terms. These are the terms. Okay, now C into, okay, this term alpha is nothing but this value. This is this C into Kc Ka by C, K into C square by C, Cc gets cancelled. Concentration of H plus ion is equal to the square root of Ka into C is the formula of concentration of H plus ions. Okay, this is information about ionization of acid. For simply up to here, dissociation constant of an acid. This is information about ostwald dilution law for weak acid, weak electrolyte. I hope it is clear. Now the ostwald dilution law is completed. Thank you. Next video we will discuss take base. If you take a basis, how to write the dissociation of bases. Thank you.